So our speaker for this session is Peter Chubb. The presentation is Shell for Starters. Peter's been using Nix systems since 1979. Has never used a Microsoft operating system, which has already once been cause for a round of applause today, and is currently working at NICTA and the University of New South Wales on trustworthy operating systems. Okay. Take it away, Peter.
Okay. What's going on here? Okay. This is a tutorial. If you actually sit down and do the exercises on your laptops, you'll remember 10 times more, approximately, than if you just sit there listening to it. This means, if I can go back one. What's happening here? I hate this.
It's catching up.
It's catching up with me. I want to go backwards. Anyway, what this means is that the people out in Videoland are going to get very bored waiting while all of you people type in the exercises. So I'm sorry about that. That's the way it is. If I can go back to the beginning again. Are we going backwards now? Yeah. I'm going to shut this down and start it again. You've just seen all of my slides already.
That's it? Oh.
No, you go further back. Further back, further back, further back, further back, further back. We're getting there, we're getting there, we're getting there. It's just ridiculous. We're right back at the beginning. Hang on. All right, here we go. This time it will work, I hope. Sorry about this. I thought I had it all set up and working, ready to go.
So the other warning I'll give is that these tables are really
wobbly.
So just be really careful with your laptops. Don't try to lock them with your legs or something.
Okay. This is a brick. Shell is all about gluing bricks together. I'm not going to spend much time talking about bricks, except that if your mobile phone goes off, it might meet a brick outside. So what is the shell? Back in the days of OS 360, Max BMS and so forth, the shell was a privileged part of the operating system that interpreted commands and set up things that your application should run. So it was only in the shell, which was privileged, that you could do things like hook up this unit to that disk over there. Under Unix, it was quickly recognised that you didn't actually need that. You could do all that stuff through system calls, and the shell is just yet another user program. You can think of it as the shell around a kernel, or if you're a user who normally sits on the command line, you can think of it as the shell that you sit inside of and reach out through to do all your work. Or you could think of it as the radiation suit that protects you from all that kernel badness. But most people think of it something like this. You've got the kernel in the middle that does all the actual talking to hardware. Then you've got the shell around the outside of that acts as a sort of thin layer to let you do things that you might not otherwise do. So you can think of it like that as your user interface to the system. Nowadays, of course, we quite often use GUI interfaces with all kinds of clicks and so forth that are started from the display manager. But if you log in on the command line, if you log in on one of those screens you get to by Control-Alt-F1 or whatever like that, you will end up with whatever your login shell is set to. Usually that's set up to be some kind of command interpreter, but it could be anything. In the days before externals, it was quite often set to be a GUI application that was GUI over serial ports. But what the shell is primarily used for, and what I'm going to be mostly concentrating on today, is as glue to stick other things together. This means that unless you've got all those other things that you understand, glue isn't very strong on its own. Unfortunately, I don't have time to go through every single utility there is on the system and work with those. So we're just going to touch on a few of the most useful ones. But we are going to talk about the shell as glue. There's C shell and TC shell that have a kind of C-like syntax. There's the Bourne shell, which was written by Steve Bourne back in 1960-something. The Corn shell, which was written by Phil Corn a little bit later, which took the Bourne shell and added functions and other things. The Bourne Again shell, which is Bash, which most of you are using. Z shell, Dash, there are lots and lots and lots of them. We're going to be concentrating on the subset of the POSIX 1003.2 standard, which is what's implemented by K-shell, Bash, and Dash. So once we've actually learned the shell, as I'm going to be teaching you, it should work on all of those systems without change. So the shell provides a user interface, which I'm not really going to cover, but it's as a programming language and the toolkit approach we're going to talk about. So in order to be a toolkit glue, you need to have some standard interface for each of the applications you're going to glue together. Every Unix process has an exit status. Usually that's 0 if the process did what you expected it to do, and it's some other number if it didn't do what you expected it to do. So if it were killed by a signal, it would have some exit status other than 0. If you run grep, which is a globally find regular expression and print, if it finds something, it'll exit 0. If it doesn't find something, it'll exit non-zero. So you can use, if you can test the exit status, you can use that as a condition code for everything else. And that is the fundamental thing you need to know in shell. The other thing is that almost every program that's useful in a pipeline, or with the shell, reads from its standard out input and writes to its standard output. And you can hook those together within the shell, either to individual files or hook the output of one process to the input of another process. It also has a standard error, which I'll come to later. But it's time for your first program. Please can you type in all of the stuff inside the box in a file. Call it ban. If you don't have sys5 banner installed in your system, instead of writing banner there, put echo. Like that. Okay? I'll give you a few moments to write that down, to type that in. When you've typed it in, do this. Shirt.slash-bank. Has everyone managed to type it in? Can I switch to a different window?
Your screen just went blank.
Did it? Oh. That's pretty useless. All right. We'll go back to that one then. This thing really doesn't like anything other than 1024 by 768, does it?
No.
I gave it 1024 by 600. And now it doesn't even want to give me back my other screen. What's it doing? I hate this. There. Good. Unfortunately, I can't easily get rid of this to show you what it looks like. But if you actually do that, you should get a series of numbers in the middle of the screen counting down. And if you've got banner, it should be big. If you only got echo, it'll be a little tiny one. And if you want to, right at the bottom here, you can have another one which says banner bang in big capital letters. And it's fun if you want a multi-user machine to stick that in someone's doc profile, so when they log in, instead of getting their shell, they get 10, 9, 8, and then bang! Yeah. The interesting thing about that program is that only the black bits are shell. Everything else is an external program. The first line, #bang/bin/sure, is a magic comment. The hash introduces a shell comment that tells the kernel that this is a shell script and needs to have /bin/sure run on it in order for it to do anything useful. X equals 9, it assigns 9 to the variable x. That's easy. Tput clear. Tput is a terminal put. It puts a control sequence to the terminal for the kind of terminal you're attached to. In this case, we do the clear, which clears the terminal. While is a shell construct, and it consists of the while, do, done. Test is an external program which tests things. In this case, it's testing whether the value of x is greater than 0. $x, dollar dereferences the x variable. So it interpolates in that line 9 in the first case, first cycle through the loop. Tput CUP 50. CUP stands for cursor positioning. 50 means 5 lines down, left hand of the screen, 0th column. Tput ED, that's ED means erase to the end of the display. Banner printed out in big. Extra is a routine which will do arithmetic or pattern matching. In this case, we're decrementing 9 by 1. Dollar parenthesis is a special construct for the shell that takes the output of whatever the command is inside it and interpolates it at this point in the command line. So, here we've got x equals $extra $x minus 1, right? The first time the shell reads that, it says, okay, x, it's got a dollar in front of it, we'll make that 9. And then it notices this and says, okay, that's a command, we'll run it. X for 9 minus 1 is 8, so that becomes 8. Next time through it'll do 7, 6, 5, 4, 3, 2, 1 and so on. And then sleep just goes to sleep for, in this case, 1 second. Okay, are there any questions about that? Yeah?
How do you write? Can you write comments in the...
Yes, how can you write comments? The hash up there is the beginning of a comment. So anything from a hash to the end of a line is a comment. Unless you quote the hash in various weird and wonderful ways, which we will come to. Okay? You can quote the hash and make it lose its special meaning as a comment character.
Okay.
But generally, if it's just on a line, if it's just on its own, anything from the hash to the end of the line is a comment. Okay, I'm going to save you some typing. If you haven't got it already, because it's on the wiki, on the tutorial page, please grab that file and unpack it somewhere, and that will save you a lot of typing. Because from now on you can just look at and modify files instead of typing all them, because they get a little bit longer.
Have you ever bit.ly and similar URL shorteners? Various URL shorteners?
Corporate policy, I can't use them. It's got to have an internet.
You guys should host a URL shortener.
I think they do, but I don't know about it. So sorry. Like I said, I actually put this on the wiki as well, on Linux Config AU wiki, so you can just click a link there. But, inside that directory, when you've done it, there's also a copy of the slides with all the notes. So you get that for free. It might not be exactly the most recent version because I was still typing on this a few hours ago, but it's certainly as it was yesterday. I suppose so, I could update it. But all the changes I made were minor, so it doesn't matter. Typos. So it should be good enough. Okay, people got that? Has anybody not got it? Okay, I'll wait for a little bit longer.
So did you say that the slides were in that table?
Yes. There should be a PDF file.
No.
No?
No.
Oh, maybe they're in the solutions, which I'll give you later. They probably are. Good. Yep. Okay. You often want to find out more than I can tell you. The manual pages are your friend. Man test will show you all the other things you can test for, so just type that in now, man space test. And you can see you can test for greater than, less than, equal, string equality, string inequality, string greater than, string less than, whether two files are the same, whether they're different, whether one's newer than the other, and so on and so on. Lots and lots of things you can test for. If you can't remember the name of a command, then man-k some keyword will search the database for you and will give you a list of all of the manual pages that have got that keyword in their name. If you're using a distribution like Debian, it will ensure there's a manual page for every command on the system. Some other operating systems are not so
Accommodating.
anally retentive, I was going to say, about making sure that happens. And you can, of course, say man should to find out what your shell can do. And that's actually quite useful as a resource. However, until you finish the tutorial, you probably won't understand a lot of it. Now, there are two things that people get wrong about the shell. And I'm going to spend most of my time on those two things. One is, how does the shell actually get stuff from the command into itself, into its belly? And the other thing is, how does it do quoting? When you've got those two things, the rest is easy. So, the shell reads commands one line at a time. First thing it does when it's got the line is it tokenizes it. It looks for things like dollars and other special characters. Once it's done that, every dollar means I've got a parameter there. I've got a variable to expand, so it expands that. It then looks for globs, that's things like stars and question marks. A question mark matches any single character, a star matches any string of characters, and it matches against the path name that you put in before that star. So if you say F star, it will look for everything in the current directory that begins with F. It then looks for command substitution, that's that dollar prevent construct, which is also spelt, by the way, backtick, backtick. Hang on, what have I just done? It's all right. Once it's done that, it splits the result into words. Each word is then immutable after that point. It's then split into jobs, which I'll come to in a little while, and finally we can execute the start command. Let's have a look at an example. Let's type, say, you type in ls-l $home/abc start. ABC starts as one spelling of that, you just as easily. Okay, so the first thing it does is it tokenizes it and finds the field separator, so that's it. And then it looks for the brace expansions. Brace expansions are only in some shells, and for some shells they're only on the command line, in other shells they're only on the command line and in scripts. However, here we've got a brace expansion. You can either spell it with an explicit list or you can give a range with a dot integer, like that's command. So that then goes through and copies the word that had that expansion in, n times, one for each thing in the expansion. Next thing we're going to look at is for variables. In this case, $home is the only variable, so it expands that. Come on. I'm running this as thread, so it's home thread. Next thing we're going to look for is globs, so we expand those. What that expands to is going to depend on what's in the directory home thread. In this case, we've got three files, archive, antelope, and colobus, but there's no file that begins with B, so the shell doesn't expand it, just leaves it as is. Right? This is all done by the shell before anything else happens. Finally, it searches $path variable for ls, finds it in /bin, and calls this system call. And that's what the kernel sees when it executes bin ls. All this is done in the shell before you get to the kernel. It's not like DOS where the kernel does the expansion for you. It's all done inside the shell, which means if you were to use a different shell, you'll get slightly different rules as for expansion. Are there any questions about that? That's one of the things people get wrong.
Yeah, just talk, well, not so much about the expansion, but the example. You've got bin ls and then ls. What's the second ls for?
This is the executable. This is argument 0. Okay. I gave you that warning before. Okay, the next one. You should already have a file called E or Echoline or E1 or something like that in that table you downloaded. So just have a look at it, make sure it's what you think it is. And then see if, based on what you've learned, you can tell what that line's going to do. When you already know what echo does, you don't know what form-x does, but I think you can probably guess. Any guesses? Yeah, it iterates over all the arguments to the shell script in this case. So have a look, find that. I'll just check what it's called.
Echoline.
Echoline, there you go. And then try it out and see what, for each of these lines, work out what you think it's going to do, and then try it and see whether it does. That, by the way, is a single space between G\H. So have you all done that first one? What do you think that one's going to do? What's going to come out when you do that on that log? Anybody? Yeah.
You'll get one line for A.
Yes.
It'll break up the words. So A, B, C, D on one line. You'll get the output from the backticks there.
They're forward ticks. They're forward ticks.
Yes, you'll get that there, and then you'll get the GH together.
That's correct. Yes. What we're seeing here is 3 different ways of quoting. These ones are not quoted, so they're just single arguments. Double quotes everything that's in between. There is a subtle difference between double quotes and single quotes, which I'll come to later. Single quotes likewise quotes in between, and a backslash removes the special meaning of the character that's immediately after it. So in answer to your question earlier, if you put a backslash before a hash, it's no longer a comment character. Right, what about these ones? If you set x equal to a shell variable, with a variable with some spaces in it, and then run this, what's going to happen? Try it and see. Yeah. So you get In this case, a shell variable. In this case, a shell variable. In that case, what do you get? $x. And in that case, $x, yes. Inside double quotes, shell variables and backtick expansions happen.
And also in the first case, a shell variable, they're all separate lines.
Yes, they're all separate lines because at that point, it's all split up into separate words. And the fact that it's just one thing, it's lost. Thank you for pointing that out, I forgot.
The difference, sorry,
Yeah.
I thought that was the difference between double and single quotes, but it's not.
The difference between double and single quotes is that inside double quotes, the dollar is observed by the shell and acted on, so it's a standard. But space is preserved, and because it's in single double quotes, it's still just one word.
So, yeah, so double quotes don't do word splitting, whereas no quotes does word splitting.
Yes. And the single quotes hides the dollar from the shell entirely. So it just prints it out as a literal. Okay? This is what everybody gets wrong. So, oh yes. So are we having fun yet?
IFS hasn't been mucked around.
Oh yeah. That's a separate issue. A separate issue. Okay, are we having fun yet? Yeah. Okay, that's enough on variables for the now, but we will come back to them. Now let's talk about redirection. The Unix process model gives every process, when it starts, a standard input, a standard output, and a standard error. And if you just say printf inside your program, it will go to standard output. If you just read, it will read from standard input, or whatever. There's a third one, standard error, where you're meant to put any error messages that you don't want to be in the standard stream that's going somewhere else. That's so that you can put your logging information separately from your processing information. And you can send them down different pipelines. When you log in, or when you start an external, all of these three file descriptors all point to the same thing. They point to your keyboard and mouse. Or keyboard and screen, I should say. When you open new files, the kernel is guaranteed to search for the first unused number. And as 0, 1, and 2 is taken, 3 is the first unused number, so it'll go on from there. You can manipulate these from the shell. A standard command looks like this. First, you've got variables set in the environment, which you can set by group equals bar, just set variables that the command will inherit. Then you've got the command, then you've got some redirections. So there's some redirections. And the command can be anything. What that does is we say, okay, we want file descriptor 3 to be an output to file descriptor for foo. And 2, we want to be the same as 3. That's what we're saying here. I'll go into these in great detail later. But what it's doing under the hood is first thing it does is it opens OpenReact OTrunc. So it creates the file and truncates it to 0 meg. That's what the on2 does. That file descriptor could be anything at this point. So the first thing it does after that is duplicate it to file descriptor 3 and then close the original. So now we have file descriptor 3 pointing at foo for output. Then we call duck2 3 to 2, which closes whatever 2 was and makes it the same as 3. And that's what that bit there does. So that's what it's doing inside, between the fork and the exec, when it's creating, when it's doing whatever the command is. The general form is n onto file, creates the file, and attaches file descriptor n to it for output. N onto and little n duplicates file descriptor n onto n. So they become the same thing. And onto and dash closes that file descriptor. If you want to turn the arrow around, so it points the other way, it does exactly the same thing but for input files. And if you want to append to a file, instead of just opening it for output, so you don't want to truncate it to 0 meg, use a herringbone instead, a double onto arrow. One very common idiom, normally you don't want your standard error output to go to the same place as your standard output because they're different things. But sometimes you do want to send them both through the same pipe, and you do it like that.
The new syntax, is that the pipe ampersand?
That is a bash instance.
Bash 4 isn't it? It's a bash, isn't it? I think it's bash 4.
Yeah.
Well, it's not even bash 3.
Yeah, it's not in the POSIX standard.
Should make it.
If you leave off n, then if it's an output file, let's assume it's file descriptor 1. If it's an input file, let's assume it's file descriptor 0. So it's standard output, and that's quick. So, quick and dirty. If you want to create a file and you couldn't be bothered starting your text editor, just say cat /temperature/food, type in your text and then hit Control D at the beginning of the line. For those of you who remember all your ASCII character tables, Control D is end of transmission. So its effect when it goes to a character divider is to take whatever's on the line so far and send it. If there's nothing on the line, it'll send a zero length read. When you're reading from a file and get a zero length read, that's the convention to end of file. So the Control D at the beginning of the line is end of file. So that's easy. What do you think on2/temperature/foo does without a command? Yeah.
It touches it and creates the file.
That's right, it'll create the file and sets its date to now. What if the file was there and very big? It'll truncate it to 0, yes. That's really useful. If you're a sysadmin and you've got something which is creating an enormous log file and it's running out of disk space and it just keeps on going, but you want to be able to capture all logs from now on, just say onto the file, it goes away and carries on. If you just removed the file, it would still be there because it's still open and things are still writing to it. And at that point, you can't get rid of it. So, it's useful. Exec is a special command that replaces the current shell script with something else. So normally you'd say, in fact, I just hit that window again. At the end of a big shell script, you might say exec Emacs. And that makes the shell script go away and Emacs start instead. If you leave out the command, what do you think that will do? Yes?
Set up redirections for future.
Yes, that sets up redirections for the current process. Because what the shell does, it sees the redirection and does it, then it sees the exec and says, oh, there's nothing to exec, I'll just carry on going. And so the effect is to make the standard output now /temp/foo. Cool? Jobs. A job is separated from another job by a new line, or semicolon, or an ampersand. You can use a semicolon or a new line for sequential operation, that is do this job, then that job, then the other job. Or you can use an ampersand for parallel operation, which says don't wait for this, just let it go. Have I got some examples? Yeah, here's two. Long running process and another running process and. That starts both processes in parallel and then we'll give you your shell format. We've talked about exit values a little bit. There's a special variable, $? which contains the exit value of the last waiting for process. So if you just type the name of a command and then echo $? It'll tell you 0 if the command succeeded or 1 if it failed, or some other number if it failed. It's not necessarily 1. Just like in C, you can use ampersand, ampersand, and or to join commands together. Let's give some examples. True, by the way, is a trivial program that always returns success. False is a trivial program that always returns non-exit, a non-zero exit status. Back in the System 5.4 days, true was funny. It was a shell script, right? Back in those days, the shell script marker wasn't a hash bang, it was just a semicolon, thing like that. So it had that, and then it had a big, big copyright notice. Copyright, AT&T, copy at your own pleasure, otherwise the lawyers will come and eat you. And then, nothing. So there's a file that's about 4K, a copyright notice, with no code whatsoever. And all it did was return a 0 exit status. I thought that was funny. Anyway, if I did true or false, what do you think $? Going to be after you've done it?
It's lazy val, true.
Yep, it'll be 0. Because the or says, do whatever's on the right-hand side if that failed. And true never fails, so that doesn't get executed. And the exit value of the whole thing is 0. What about true and false? That one there. What's that going to give you?
Non-zero.
Non-zero, yeah. In this case, it's 1. What about false piped through true? Yeah. The exit status of a pipeline is the exit status of the rightmost command in it.
Why is it so different?
Because true is the rightmost command, and it succeeded.
0 is true.
0 is succeeded. 0 is success, non-zero is failure. Okay. It's the opposite way round to C. Yeah. Okay, here's some real-ish examples. In this case, I want to find out whether my name's an essential password or whether it's being sourced from LNAP or something like that. So I say grep p2c essential password onto dev null, which throws away the output. Dev null is a special file in dev that eats up anything you give to it, and if you read it, will give an edit file immediately. It used to be, back in edition 4 days, called dev battle. But dev battle.
Oh, okay.
Because things went in, nothing came out. But when it became officially released in edition 7, it got changed to dev null. 2 onto round 1 throws away any standard error. And we've got the double OR. The new line after the double OR, the shell knows that we haven't finished yet, so we don't need to do anything to quote that new line there. We can just carry on there. In this case, we're going to echo onto round 2, so this is going to go on to standard error. P2c not in password file. So, if the grep command finds me in the password file, then it won't output anything. If it doesn't find me, the echo will happen. And either way, I'll get a true exit status. Okay? Good. Path. There's a swag of variables that are special to the shell that consist of names of something separated by colons. Path is one of them. Path tells you where to search to find commands. In this case, we're going to look in /bin and then /userbin. If you don't start your command with ./ or /something, it will always start and search for the stuff in userbin in this case, or whatever else you could command in. I typically have a binaries directory in my home directory, and so that's in there too. But path isn't the only one. There's also a swag of others that you can look up in the man page of the shell if you want. But 2 important ones are cd path and mail path. CD path controls what happens when you type CD. In this case, I've got dot and $home. Dot means current directory. So when I type cd doc, it will first look in my current directory. Is there a directory there called doc? And change it to that. If there isn't, it'll search the next one, $home. That's my home directory. Yes, I've got a doc file, a doc directory there. I'll change it to there. So that's quite useful. Mail path was designed for those days before you had multi-windowing systems. And the idea there was that every file in here would be checked every time the shell put out a prompt. And if it had changed since last time, it would print out the string, you have mail. That's very nice, because now you've got something in your shell that while you're typing along, will tell you if files have changed their name, changed their time. So when you're on that SSH connection via ISDN link to Japan, which is going under sea cable, so it's a 40 millisecond delay while you're typing, you can type your make, and then as the last thing in the pipeline after make, so you're building a big system, so you're doing make all. On the same line, you say and echo onto foo, and have foo in your mail path. Then when it gets updated because this thing's finished, you'll be told. And in the meantime, you can be editing some other file. Just the sort of thing you can use that for. All right, let's explore half of it. I think that put is called mywitch or something like that in there, in the shell examples directory.
Yeah.
Have a look, see whether it's the same as this or roughly the same as this.
Actually, do that.
Yeah, I've got 2 different ones.
Is the CD path strictly required? Because I don't seem to have it.
If it's not there, it'll just be dot, the cover directory. But if you set it, it'll go somewhere. If you don't want to get totally confused, never have a CD path that doesn't have dot as its first element. Because otherwise, you do an ls, find out where you are, see what the file is, then CD to something that goes somewhere else. Yeah.
We just need to have it go cd.slash.
Yeah, you could do that. All right. There's an X in there that's not meant to be there. Sorry. Again, we've got for arg, which goes all the way and iterates through all the arguments of this function. And this time we're going to say for dir in $path. But we've already seen that dollar variables will be split on word boundaries. So we want to tell the shell to split this on colons. So we set IFS, which is the internal field separator, to colon. So when this gets expanded by the shell, path becomes a word for each element of the path variable. And so this for dir in $path will iterate over all of those. And then we'll test, is there an executable called arg in that directory, and if there is, echo it out. All right. Try the program, try it on a few different things. The nice thing about this one, there's a standard program called which will tell you which one you're using, but it won't tell you if that's masking some other one. This one will tell you all of the ones in your path. So if you've got GCC in userlib Ccache and in user bin, it'll tell you that they're both there. All right? So that's IFS. Have a chance to try it.
So that's currently, if we want to test for multiple programs,
Yep.
we actually have to column separate.
No, on the command line it's already been done and given to you before it gets this far, so it doesn't matter. Neat, eh? Okay, there's not much more infrastructure to talk about before we get on to the interesting stuff, more interesting stuff. I did want to mention set. As you know, every Unix command just about, except for the ones that are joke copies of other commands, like dd. You've got some command, and then you say dash some n dash p dash something. And ls is ridiculous because if you type ls, almost any letter works with it. Shell is no exception, and there are three that are really useful: dash x, dash v, and dash e. Dash x displays every command before it executes. So with that which or my which or whatever it is, I can't remember what it's called in there, try show dash x dot slash, what's it called, my which?
It's WH.
WH.
which is huge.
LS, say. And you'll see that it prints out each line as it goes. That's really useful for debugging.
It prints out each line as the shell shows it. As
the shell executes it. Yes. So it's already done some of the variable expansion.
Yeah.
Yeah.
Which is useful.
Dash V will display the commands as they're read. So try the same thing with dash V. That's useful if your shell script is sourcing other shell scripts all over the place and including them. Because sometimes you transfer something you didn't expect to because the value of path wasn't what you expected it to be. And dash E is a helper for you if you can't be bothered doing proper error correction and detection. It just says exit the shell script entirely if any command fails. That's sometimes what you want, but not always. What if you want to set this just for a little bit of your shell script? You've got a huge shell script and you want to do something small. Well, you use set. Set is a command that will rewrite the shell's current command line, as it were. So if inside your shell script you say set dash x, I can't spell, dash x, that's as if you typed dash x on the command line. But it only applies from that point in the program on. So one really nice debugging feature, let's say you've got a shell script that's invoked when you do when you bring up a PDP virtual private network or something, and it's wrong, and you can't find out why. Inside you say exec 2on2/temp/log set-x, and from there on, everything that script's doing is put into that file for you. Actually, you probably want to do onto. So you can get it multiple times if it does it multiple times. And then you can actually go in and find out what that shell script was doing when you couldn't tell. The other thing you can do is, there's after the set dash option, that can let you set any shell option. You can say dash and then arguments. So shell scripts have arguments. You can set them inside the shell script, probably after you've dealt with the ones that came from outside. And possibly after you've filled with IFS to expand variables that have colons in them. So here's an example. I'm not expecting you to publish this in. GetEnt is a program which looks up system databases like the password database. It'll look up LDAP or whatever PAM says and give you the password file in this case. So we're going to say x equals getEnt password $1. The backtick's the same as the $parentheses we saw before, just a different spelling. In general, you should be using $parentheses because it's much easier to do nested ones. With these, if you want to do nested ones, the quoting gets really heavy. So we're taking $1, which is the first argument to the shell, calling getEnt password on it, then we reset by the field separator to colon, set $x, which then splits it into words based on colons, and the seventh field of the password file is the user's login shell. So in this case, let's say $1 has shell, $7, Peter has shell, bin shell. Yeah.
You quoted IFS colon here, you didn't previously. Does it need to be quoted?
Yes, because colon is special to the shell.
In a previous example, it was just IFS equals colon.
Yeah, it doesn't really matter. You can do it either way.
Okay.
It's still going to be just one character. Okay. Let's talk about variables a bit more. We've talked about variables being dereferenced or expanded by $. You can delimit variable names with braces. So if you've got some variable name you want to make as part of a longer string, you can put braces around it. I've got some examples on the next slide. There's a few special variables. We've seen one of them. We've seen the exit state of the last job there. And there's also a $bang, which is the process ID of the last asynchronous command executed. There's $hash, which is the number of arguments to the shell, or to the shell function that you want, or to the last set command. And there's $0, which is the path name to this script. Now, $0, depending on what your environment is, might be just the last portion, just the file name, or it could be the complete directory name and the file name. And you don't know at the time. It depends on the environment you're in. So it could be other. There are others, but these are the most useful. See the man page or the POSIX.2 spec for the full list. So here's some examples. I'm not going to make you run through these this time. If you set foo equals home thread, economic foo, you get it, as you said. You can then use it here. It just gets replaced with home thread before the CD happens, as we said before. And there we are. If you set b to some big program, and then type $b, it just gets expanded there and run. So that's easy. But there's something else. Let's say we set foo equals bar. If you just type set on its own, it prints out all of the variables that are set in the current shell, plus all of the shell functions that are available. So, if we then take set pipe to do grep foo, you get foo equals bar. Try that. Remember, set is a shell built in. It's actually shell off. It's operating on the state that the shell has internally. There's another command, env, which shows you what's in your environment. It's a separate outside program. So it looks at all the variables that it can get at. If I do this, just after that bit, what's going to happen? What's going to be output? Nothing whatsoever. If I then mark foo for export, it'll move foo equals bar from just being an internal shell variable to being something that's in the program environment that can be inherited by children of this shell. If I then do in pipe foo get foo, you get foo equals bar. There's a few special parameter forms, some of which are really, really useful and some of which are less useful. These ones are the two that I find most useful. Parameter is just the name of the shell variable, or one of the arguments of the shell. And then there's two characters, colon dash in this case. If the dollar parameter has a value, it'll use it. That's what that expression will expand to. If it doesn't have a value, you had never set it, or you explicitly set it to the empty string, then whatever word is will be expanded at that point. If you leave out the colon, then you can explicitly set the parameter to null, and that will be used. And it's only if it's never been set that the word will be replaced with it. Parameter colon equals word expands to parameter if the parameter is set and non-null. Otherwise, it will assign the value of word to parameter and then substitute the value of the results. A really simple example is in my build scripts, I've got something like this. Colon is a no-op in shell. It says do all the parsing and expansions that you do otherwise and then do nothing.
And it returns true.
And it returns true, yes. Really useful that one. In this case, we're going to say, okay, if CC is not set, set it to GCC 4.7. Otherwise, don't do anything. And that's my build script. And I can set CC on the command line, and it'll override that. Otherwise, it'll just pick up its value. Do you have a question?
Wouldn't it be clearer to write CC equals dollar continue? Like to make it clear that you're setting CC. I look at that, I know what it does, but it's confusing to me that if you'd written CC equals at the front, it'd be obvious to me that it's setting the CC variable.
Yeah,
I know the demonstration.
This is the idiom that's been used since 1979.
I've done that way.
You need to get used to this because you'll see it.
Oh, I see it a lot.
Yeah, it's the same thing. I mean, you could put CC equals there again, but that will actually do more work in the shell because the shell doesn't optimize.
Yeah, I understand.
Yeah.
You're using shell, so you don't care about optimization.
Well, you do to a certain extent.
Yeah.
Quoting, we've already met quoting. So I'm going to go through this really quickly. Backslash removes the special meaning of the next character. Single quote prevents all expansion, and everything between the quotes becomes a single word at that point. Double quotes allow parameter and command substitution, so all the dollars get expanded, all the dollar parentheses get expanded. If you're in a modern shell like Bash, which has got extensions, all the arithmetic stuff gets expanded, and so on. But after it's done all that stuff, everything between single quotes is a single word. So, here's some examples. We've gone through this before, so I'm going to go through it fairly fast. In this case, we go dollar with that, we're going to get that with the space preserved, there's just one word. With the backslash, it turns off the meaning of the dollar, so what we're going to see? Yep. If I echo just dollar H, what we're going to see?
Without the leaving space.
Yeah, without leaving space. And you can guess what these other ones do. The only ones to watch out are this one, right? You can try that one both with and without double quotes and see what you get. When you see it, you'll know why. So, you done that? So echo x dollar h gets expanded to echo x. Dollar H is a big space, then foo bar. So echo sees three words. and prints them out and separated by one space. So you get X, foo, bar coming out in just one space, not a big long one. Basically. If you put double quotes around it, then Echo just sees one line, including one word, including that, and that's what will come out. What? I said before you could delimit variable names with braces. So if you want to make foo bar X instead of just foo bar, you can't do that because that becomes a new variable named .hx, which doesn't exist. So you don't get anything out. Whereas here, $h is expanded and Echo sees foo bar X and prints it out properly. Get it?
Just the slide isn't entirely clear on the first line and there's actually a lot of space there.
Oh, okay. There's meant to be 2 or 3 spaces there.
It's not like I've exaggerated. You've got it in there probably for real, but I've exaggerated.
Yeah. It is actually exaggerated, but latex sort of scrunched it up again.
Well, you just need to put a whole bunch of non-blocking spaces.
Yeah. It's got two quad spaces in it, but hey. Anyway, good. Parentheses. There's 2 different sets of parentheses for starting groups of things. Parentheses on their own start a subshell. Within a subshell, you're actually running in a child of the shell, a separate process, which means any variable changes you make in there are not going to be visible to the parent. Any change of directory in there you do is not going to be visible to a parent. Any internal redirections you do is not going to be visible to the parent, but you can redirect the whole thing as a group. So, for example, cd / echo star ls and pipe the whole thing through ls, which is my favourite pager. You'll note the semicolon there. You need that because otherwise the parenthesis there becomes an argument to ls. That change of directory there is not effective in this environment here, only inside the shell that starts there and ends there. And the whole of the output of all of that goes into this. Okay? Braces start a simple group. If you make a change inside a variable group, you're still inside the same shell, so variable changes are visible outside. If you change the current directory, that will change it outside as well. If you redirect inside, it gets redirected outside as well. If you do an exec onto blah or whatever. And again, you can redirect out from the whole group. So what does it do? It groups things. So here, in this case, I'm going to echo all of that stuff and then category password, and I put the whole thing through this. So we've got a group of commands, 2 in this case, that together have the output through this. Although they're projected together through the pipe. In this case, I'm just adding a heading, which is boring. It becomes more interesting in that a group is the body of a shell function. But before we do that, I shall mention some about here documents. This is a here document. The herringbone there is exactly like the append herringbone but the other way. So in this case, we're going to take standard input from the stuff that's in the shell. The thing after the herringbone, ignore the dash for now, is any token you care to type. It doesn't matter what it is. It could be anything that's not a shell special character. And the input to the commands there is anything that from the next line on up to the first instance of that thing, whatever it was you typed. In this case, I typed anything goes. You could just use it EOF or thread or on commands or whatever. The dash there says ignore tabs at the beginning of the line in here, so strip them off first. That's how you can indent this within a shell script. Within here, shell variables and brace expansions, not brace expansions, sorry, command expansions happen. So you can put shell variables in there to customize your whatever. I think I've got an example here. So I've told you this. You can add a dash to ignore tabs. The other thing is if you quote any part of that string by any of the quoting mechanisms we've talked about, then the whole of the block is quoted, with the exception of stripping off those first tabs. And at that point, you can put dollars in there. It's also slightly quicker. If you don't have any command substitutions in there, then the shell doesn't have to read it and do all this parsing. So if you've got something big that you're doing in this way, just an error message or something like that, and you're not customizing, quote some part of the string and it'll come out a lot faster. Okay, so here's an example pipeline. I'm not going to give you to try and type this now because it takes forever to run anyway. But here we're going to go through every single text and HTML file inside UserShare doc, which is where documents are dumped by the Debian system and Ubuntu and all those things. Then we're going to transliterate upper to lower. Then we're going to throw away anything that isn't a lowercase character and convert it into a new line. And then we're going to sort it and put it into distinct words. This is just an example of a longer pipeline. And also introduces TR. Cat, we've already seen it, concatenates all its arguments and sticks the result on standard output. Again, if you've got a pipe at the end of the line, the shell knows that the job hasn't finished, so it'll go on to the next line and you can just carry on typing. It might even give you a separate prompt if you're lucky. So that creates a word list, and this is actually the way that the first spelling checking program was created under Unix back in 1970, I forget, 4 or 5, when AT&T was first starting to use Unix in-house for developing documents. And someone said, it'd be really nice if we could spell check these documents and not have to do it by hand. So they'd already got this great corpus of documents. So they did something like this. The syntax of TR has changed slightly over the years. This is the modern one. Back then, you did slightly differently. And created this word list. Then you can do the same thing on the document you're trying to spell check and get a different word list. And then you can just compare the two word lists. Any word that's in the one you generated from your document that isn't in the corpus of spell check words already is a spelling error, or it needs to be added to the corpus. Easy, eh? So once you've done that, you can start doing some interesting things with it. Shell's got while, if, until, case and for. They're almost the same as the ones in every other programming language, so I'm not going to spend too much time on them. The only thing to watch is that while, if, and until take the exit status of a command as the thing to check on. And we'll see some case examples a little bit later. We've already seen for. So here's an example using that word list we just created. If grep, which stands for globally find a regular expression, print zoom, beginning at the beginning of the line and ending at the end of the line, stand a regular expression in September, throw away the result, then echo zoom, else echo slow. Right. In general, unless you've got quite a bit to put in here, you can just use the ampersand, and bar and get it done in a shorter space. But sometimes for clarity, you can use the if then else. And if you've got an else part, you quite often want to do if then else.
Can I note that the ampersand, and bar isn't exactly equivalent?
It's almost equivalent.
It's close, but if the thing after the double ampersand fails, then the else case will never happen.
Yes, that's right. You can't generally use ampersand and the double bar together because bad things happen unless you're careful, very careful. And if you are very careful in that way, you muck up your exit status from the whole thing. So, yeah, so that's good. For iterates over its arguments, we've already done it. We've seen the for iterating over $at, which is all the variables of the shell, or all of the arguments of the shell. And we've seen it that way too, so I'm not going to go into it anymore. What I'm going to do now is go through a slightly longer example that I quite often use. This is a shell script that I wrote to help me manage my cluster. I've got 10 machines that I want to find out whether they're responding to SSH or not. The problem is you can't just ping them because they respond to ping even when SSH has died. So what I wanted to do was devise a program that would tell me whether they're responding to SSH. So this is it. This is the shell function. Shell functions, you just give it the name of the function followed by two parentheses, and then a curly brace group. And whenever after this you type is up, this will be done. So in this case we're going to SSH to $1. $1 in this case is the argument to is up, not the argument to the shell script. And sleep 1. And we're going to put it in the background and remember the process ID of that SSH process. Now normally, assuming you've got your key server set up and all the rest of it, that'll take about 3 seconds. It takes about half a second to look up the DNS, about a second to do the protocol, key exchange, Diffie-Hellman, whatever else it does, and then about a second to sleep, and then it'll return with an exit status of 0. Okay? That's it, everything's up. But it might not be up, and the network might be slow today, so it might take longer. So at the same time, in a subshell, we're going to start at sleep 15, and after 15 seconds, we're going to kill that process. All right? So kill -9. And we're going to throw away the result instead of 9. And we're going to put that in the background too. We're then going to call wait on that process. Now, if that happened within, say, 3 seconds, it'll return an exit status of 0, and that wait will get 0, and the exit status of the whole function is the exit status of the last command that got executed, in this case wait. So this whole thing will return an exit status of 0. If it's still hanging after 15 seconds, then it'll get killed. If a process is killed, it returns a non-zero exit status. So this wait will then return a will become a non-zero exit status, and the whole function will give a non-zero exit status. The result is that if I type is up some machine name, it'll try to SSH to it, and if it fails to SSH within 15 seconds, I get a non-zero exit status. If it does succeed in the zero exit status, then it will immediately come back and tell me it's up. There is one gotcha with this. There's just a chance that if you've got an incredibly busy system, and it has to be incredibly busy, or you're in a virtual machine of the vServer kind, which gives you a limited range of process IDs, your process IDs might roll around in those 15 seconds, in which case this PID might kill the wrong one. So ideally, here, we kill this process. But I haven't put that in. I leave that to your exercise for the video. That's okay, so how do we use this? Well, we're going to do this. This is inside a script, and the script takes a list of machines, and we're going to iterate all through those machines and do this. We're going to type is_up_x and $x onto file descriptor 3. Outside the shell, we're going to redirect shell file descriptor 3 onto 1, and we're going to make file descriptor 1 dev TTY. That's because SSH, if it hasn't got a key server to talk to, we're asking for a password. And it wants to talk to dev TTY to do that. So that gives me a chance, and it says, oh, I want a password. Quick, start the key server. and let it in. And we'll collect the process IDs of those things in PIDs, so we can wait for them later. There's no way in the shell to wait for more than one process at a time. You can only wait for one at a time. So after that, we'll set met equals 0, iterate through all those processes and wait for them. And if any of them fail, we'll set met equals 1, and we'll exit with that code. So now we have a program, a shell script as a whole, that you can give it a list of machine names. It will attempt to SSH to all of them, and will tell you if any of them is down. What's more, if you look back there, if it is up, it'll tell you that it's up. So you get a list of all the ones that are up and an exit status that says that one of them is down. Maybe. Okay. We saw some shell arguments there, but I want to talk about them a little bit more extensively. That is up program, by the way. It's slightly more examples in the solutions, which I'll tell you how to get in a little while. Your shell arguments are available to you either as individually, the first 9 is $1 through $9, or as a complete set, either as $*, which throws away any spaces and unquotes everything, and it's not very useful, or as $@, which if you put it inside quotes, becomes effectively this. And so on, with a single space in between each one. Which means that you can say for I in $@ with quotes. If you leave out the quotes, bad things will happen.
So are you limited to that number of shell arguments?
We're not really limited. We'll come to that. Watch the quoting. Shift throws arguments away. This is where you come to. If you just say shift, it will throw away argument $1, rename $2 as $1, rename $3 as $2, and so on. And the previously invisible 10th argument becomes $9. You can give shift an argument, which is a number, and it will throw away that many. So you can throw away 9 at once if you want. So we saw the echo line command that we saw before. This is another way of writing exactly the same thing. This time, tests $1. Test, if it's just given a string, will return a 0 exit status if the string is of non-zero length. So while there's anything in $1, we'll echo it, and then we'll shift, which renames $2 as $1, and then goes through again. So that's another way of doing exactly the same thing as we did beforehand. And depending on what you're doing, sometimes one is more convenient, sometimes the other is more convenient. In particular, when you're handling arguments, I'm going to talk about getops in a little while, but we need to use that. I see this far too often in student shell scripts. What this does is it starts a process reading a file and then dumping in 4K chunks into a pipeline. Every time 4K chunks go through, 4K goes through, it has to stop to let the pipeline go on. Then the pipeline starts, and when it runs out of input, it'll stop and cat will start and dump another 4K into there. That's horrible. It's horribly inefficient. And you don't need it because your pipeline reads from standard input. So let's just say standard input is the file. The other thing to watch out is minimize the use of external processes. If you're using a while loop in shell, you're probably doing something wrong. If it's got anything serious inside that while. And you might want to use a different process like Python or Ruby or something. If you're going to do something expensive, do it once in a pipeline. If you can rephrase your problem as a filtering problem that goes one thing to another thing to another thing to another thing, it'll go a lot faster than if you're going to do something which iterates over a file, dumps the result to another file, iterates over that file, dumps it into a file, Okay? So let me give you an example. This one is from Puppy Linux. Who uses Puppy? Yeah, a few people. Brian used to have a script for creating Puppy. This was about 3 years ago. And there was a big chunk of it commented out because it made generating the ISO take 5 hours. What that was doing, oh sorry, not this one, I'll go to the next one. This one. It was trying to find out which shared libraries were missing on in the library. And what it did was it went through, found all the executables and dumped them into a file. Then it would do a while read from that file. Then it would look to see which shared libraries it was. And then it would iterate over them to find out whether they were there or not. And I said, 5 hours. I wrote it like this, and it now takes 30 seconds. Okay, so what we're doing, find is a really useful workhorse of a tool. What it does is it looks for files of the kind that you've specified. In this case, we're going to find in the current working directory anything that's an ordinary file, that's not a directory, not a character device, not a block device, not a pipe, not a Unix topic. With permissions with at least these bits set, that means it's executable. At least one executable bit set. And we're going to operate on it with the print0 command. That says, put its name on standard output, and then put in a null character, a 0 character. Pipe that through xargs-0 file-n. Xargs takes a sequence of words on its standard input, a sequence of lines on its standard input, and puts them at the end of whatever comes after its options. So in this case, it's going to run the file-n command with all of those file names. We've just given it. One file name per argument. Because file names sometimes have spaces in them, we're using print0 and a -0 there. And that says instead of separating on new line and space for the file names, separate on the null character. So at this point, if we just type that, you'll get a list of all the executables of the system. Pipe it through xargs, and you'll see a file will tell you the kind of all those files. Because we only want to do this on ELF executables. So then we use sed, which is the stream editor, and it's a really useful workhorse for using inside shell. And I wish we had time and scope in this class to go into it because it's really fun. We look for all the ones that are ELF executables and throw away everything. There's a \1 there that you can't see that comes after the colon at the beginning. So the output of file-n is file name, colon, file type. In this case, we want some kind of ELF executable, which is dynamically linked. We don't care about the same linked ones. And then we'll pipe that through xargs, and this kind of an attribute into the current directory. So we've only got, so we can use LDD in the new file system. And dig out using awk, looking for not found and print the file name and the library that's missing. So then we can see that for some reason the window manager is missing one of the GTK files already. And like I said, that took 30 seconds to a minute to run, whereas before it was taking 5 hours. And the reason for that was by reworking the problem, instead of being a iterative problem where you're iterating with nested loops, we turn it into a filter. And in general, if you can turn things into a filter, things will go much, much faster. And the xargs is your friend for that. Okay?
Can I ask just briefly why you didn't use find-exec instead?
The question is whether we're using just find-exec instead. The problem with find-exec is that it spawns an extra process for every single file it finds. Whereas this just spawns one process.
You can use -exec with the plus option as opposed to the semicolon.
That is not actually the POSIX standard, it's new.
Yeah, it is part of the POSIX standard that you're specifying.
Okay, well I didn't know that. But this works, so. You still need the rest of the pipeline anyway.
Yes.
And xargs in general is faster. I don't know why, but it is. Okay. Cleaning up after your droppings. Every now and then you want to create a temporary file, and you want to clean up after your droppings. This track says, when one of these signal names happen, do whatever's in there. And this is not actually going to be evaluated until that happens. So you can add temp files you can add your temp files into the temp files variable one at a time, and then remove them all at once when this signal happens. 0 is a special signal, it's not a real signal, that just says when this shell script exits. So what that says is, when this shell script exits, do that command, and that this file will add temp files into temp files, so at the end, you'll throw it away. That won't work in the subshell if you call temp file foo. It's only going to work locally, and it will only work if temporary file names don't create special characters. But that's one way of handling your temporary file and making sure you don't leave any droppings around. Because there's nothing worse than running someone else's script a few times and finding /2 with 10,000 files on it. GetOps. We talked about option arguments a little bit before. GetOps is your friend, and I always get it wrong when I try and use it. GetOps only works in a while loop. It's semi-built into the shell. What it takes as first argument is a list of names arguments. So in this case, we're looking for switch -n. If a letter has a colon afterwards, it means it's got an optional argument as well. So in this case, we're looking for something that looks like -n3 or something like that. And we don't care whether it's -n3 or -n3 on the command line. Okay? So we do say while GetOps n and then the name of some variable. It doesn't matter what it is, your choice. Do. And you typically do this with a case statement inside. The format of a case statement is case, some string, in this case it's the expansion called C, in, and then a pattern to match, followed by a parenthesis. If that pattern from GetOps, if after running GetOps once round the loop, C contains n, this branch will be done, and we'll set number equals $optarg, which is a special variable that contains the value of the optional argument. double semicolon says that's the end of this branch. Star matches anything, and in this case we're going to call the usage function. Again, you've got to close off the branch and close off the whole case statement with SAC, which is case spelled backwards. After you've done that, you always do a shift $opt-end. That will throw away all of the variable, all of the arguments that GetOps has processed. And at that point, you've just got your normal launch and arguments to play with. Right, we'll see some examples of that later on. Now, there's a complete example finger, but I'm running out of time, I think. What's the time? How much time have we got?
15 minutes later.
Yeah, so we're going to forget that. You can look at that for yourself later. You all know about the finger command. Normally you type finger some name and it will tell you everything about that person. There's an implementation in Shell that's not too bad, not too inefficient in the examples directory you can have a look at. What I wanted to do that is to go onto the Fables server. Now I'm hoping that this is still up, but if you tell that to that on port 8500, you'll get an idea of what we're going to do. This is written entirely in Shell. Right, do you see what it does? Gives you an ESOP file. It's fun. ESOP 11.txt, it's worth having a look at that file and see what it looks like. You'll see it's got a whole heap of Gutenberg boilerplate at the beginning that's got the licensing conditions under which you can copy that and spread it around, which is close to the Creative Commons license, but not quite. And then it's got a number of blank lines, and then it's got fables. And every fable consists of a title, then a blank line, then a whole heap of lines under the fable, possibly with other blank lines in there, and then 2 blank lines before the next fable. Now, how could you write a shell script to pick out one fable at random? Any ideas? Remember, you want to be reasonably efficient.
Now, when you're saying entirely in Shell, does that mean without calls to separate?
No, you can use sed and org and lex and gap and anything else you want it for. But doing the whole thing in Python and just having that in there is cheating. Okay, we could count the lines in the file every time, then search backwards randomly for a random number, and then search backwards to the beginning of a fable, and then print it out forwardly. If we did that every time, it's going to be incredibly slow. Yep.
Well, you could use sed if you created an index.
Yes. Create an index, and then grab a fable. So, I've got some solutions here. If you do ./get solutions in your thing, it should, assuming the server doesn't melt down by all of you doing it at once, grab some solutions and expand them into your file. So do that now. And we have 2 indices. This is where I wish I could switch to another console and have it display, but it doesn't work. So sorry about that. You people have to do it yourselves and have a look at it. There's 2 indexing functions in there. One of them is set up as a call out to org to do most of the heavy lifting. The other one tries to do it all in Shell. If you run each of those, you'll find one of them takes a few seconds and the other one takes a lot more seconds. And again, it's a matter of using the right tool for the job and using Shell as a glue between the tools. When you've done that and had a look at it, take a look at the fable command. Try it out, see that it works. You will need to build the index first, of course. And then what I want you to do is to think about how you could change fable so that instead of just giving you a random fable every single time, you could select your favourite fable. I want fable number 33 this time. If you're really clever and looking for something to do, you can take either a fable number or a keyword for a fable. So I can say, I want the fable about the fox and the geese and the wine. So that's your task. And while you're doing that, you can ask questions. Sorry, all you people out video lines are going to be boring. There's some useful tools, and this is about my last slide. We've gone through all of these in some extent. The only ones I left out are base name and DNA, which extract parts and file names. Talked about all the others.
Which incidentally you can do with expansions if you want to do something that's not particularly readable.
Yeah. Base name and DNA are reasonably readable, and they've been there forever, and they're even in the version of Shell you get in BusyBox, whereas the expansions aren't.
That is true, yes.
Yeah. One other thing to mention that I haven't mentioned yet is that test has an alternative spelling.
One character spelling?
Yes, two character spelling actually. Square bracket. So that is exactly the same as test, except sometimes looks nicer if you put it in an if or a while or something. And if you look in user bin, which I think is where it is, it might have been bin actually, you'll see that that is actually a symlink to that or a real link to that.
And most shells have both as a built-in, I think.
Yes,
most current shells.
a lot of the current shells have that as built in, but it doesn't matter, it's not a real external command.
Yeah.
That's a double square, right?
Yeah,
That is definitely built-in.
yes, that's built in because it will be better. Yep. Yep.
What's the relationship between the shell syntax and C?
What's the relationship between shell syntax and C? There's none. There's completely separate programs. It's the people who wrote the Bourne shell initially with C programs. Although the initial, if you've ever seen the original Bourne shell code, the person who wrote it, Steve Bourne, was a Pascal programmer. So he wrote heaps and heaps of CP processor macros to make it look like Pascal.
What's your preferred reference number?
What's the best reference manual for Shell? The O'Reilly book is reasonable, but I prefer to go straight to the standard. POSIX 1.3.2 used to be online as part of the Austin Boots releases.
Yeah.
I don't know where it is now.
Ops.opengroup.org.
Opengroup.org, okay. Yeah. It's pretty good.
It's there.
If you stick with what it says, it's actually pretty readable for standard. Then you're pretty sure that what you do will still work under dash, bash, K shell, Z shell, whatever.
Can I also recommend the hash bash chat room on Freenode? If you say, I want to program in called shell, they will help you with that.
Yes, they will.
Heaps of references. I spend a lot of time in there.
And check maybe is pretty helpful too.
Sorry, what was that?
Check maybe.
Yes.
Is it worth talking about when not to use shell?
Yeah, sure. An awful lot of the commands in Unix started out as shell scripts. And as they got used, people thought, okay, this one's a little bit too slow. I'm going to switch to a C program. In general, I find shell really good for quick and dirties and things like that is up where it's mostly manipulating process data and I know how to do it backwards. Any time when you've got to start iterating over data as opposed to putting it into a pipeline, use something else. Anytime you want to do heavy pattern matching, use something else. Anytime you actually want a type system, use Haskell or something. Okay? And in general, what I find is shell is really, really easy to prototype stuff in fast. That's for me, most of the time. But that's because I already know Sandbook and so on, so I can just use that for things there. Use whatever's most productive for you, whatever switching language. And then if it's fast enough, what you want, you're done. If it's not fast enough, you might need to do something else. There's another question on the back.
What do you think of ZSH? Do you think of it as something completely different? Like,
I don't know. The question is, what do I think of ZSH? I've never used it, but some of my colleagues swear by it. So, I don't know. I tend to stick to the positive subject.
Just as a comment, Z-Shell has a lot of good stuff for interactive shell.
Yes.
So if you want to write shell scripts, keep to what we've done in this tutorial. But if you want an interactive shell, Z-Shell's what we'll do.
Yeah. It's like the difference between TC shell and C shell. I didn't go through any of the interactive stuff that's in the POSIX standard. The core shell introduced all these neat things for history and command line editing, all of which, by the way, was stolen from TC shell, which are really neat and really useful, but it's more interactive use of the shell, not this. Another question on the back? Okay, I thought you were waiting.
How obsessive are you usually? I'm really obsessive with quoting.
Yes.
Particularly in hash bash. I mean, we get a lot of new people, and 95% of the time, their problem is they haven't quoted properly.
Yes, exactly.
And
that's why I spent half this thing on quoting.
Well, I did notice, despite that, you've got a few variables that you have that you don't quote expansion, and most of them are pretty much guaranteed to result in a number or some value.
Yes.
But I find that quoting, we've got a shortcutting in bash that says quote everything, unless you know that for some bizarre reason you don't want it.
That's right. Quote. In general, quote. The only time you don't quote is when you explicitly want the shell to split up into words after it's been expanded. And even then, sometimes you want to quote and use eval, which I haven't shown you.
And another thing that I think is eval is usually the wrong solution. It can be, it can come in handy, but
it's useful maybe 1 in 10,000 times.
Yes. But most of the time, if you're using eval, you're trying to solve the problem the wrong way.
Yeah, that's right. Which is why I didn't put in the ooh.
That's completely right.
That's my daughter wearing her catsuit.
Process substitution and filters and loops.
Yeah, sorry about that. I'll get back to it. Are there any other questions? We're almost at the end of the talk now. We've got about 2 minutes to go. Yeah?
Curious, it's very, not a very abstract concepts, variable region, language region. Is there any way that someone could actually interact with the shell when they don't really and I think more visually or in terms of concrete objects and interactions?
The question is there some way of interacting with the shell? If I can paraphrase, as a graphic designer instead of as a programmer.
Basically, because it's very, it's even more abstract than, the current object-oriented type of program. It's basically variable programming.
Yeah, it's basically glue for sticking other things together.
Yeah, it's extremely abstract.
Very abstract, yes.
I mean, it's very powerful, but is there... Some people just don't think that way.
People have tried to generate graphical shells where, you pull commands and wiggle them up and join them up with pipes and so forth. I don't know of one that's actually become successful. But there have been dozens of proposals, dozens of ones that have lived for a little while and disappeared. So I don't know of any.
Or maybe they're not marketing it correctly.
Or they just don't never work properly. Yeah. Any other questions?
Just as a comment on that, there are some interesting shells that do something like some magic words to try and cap an image file. They'll actually render it in the show window and things like that.
Yeah.
The actual show it. Kind of
Yeah.
something like that.
But then some people use Emacs as their shell. Yeah. Okay, I think we're done. I hope you had fun.
On behalf of LCA 2013 and Linux Australia,
Oh, cool.
a small gift.
Thank you.
Thank you.
We'll have to give you a big gift.